Okay. So saying hi to Shay and to maybe Laura. Maybe Laura's coming. I don't. We hope so. But regardless, guys, you can even look back on this video. Hey, look, law of cosines is true for all triangles. All triangles, not just right triangles, but obtuse triangles, acute triangles, you name it, it's good. And that's what makes the law of sines and law of cosines so powerful. You're not restricted to right triangles. But look at the form. There are three different equivalent forms for the law of cosines for any one triangle. C squared equals a squared plus b squared. Kids would be like, wow, that sounds like the Pythagorean theorem. Yeah, but there's more. Then you'd say minus 2ab, those two terms on the right side, times the cosine of angle C. Notice how the side that is isolated on the left shows up in the angle inside of the cosine. Always. So by way of comparison, we could have b squared would equal a squared plus c squared. But now we're going to say minus 2 times those two terms, minus 2ac, cosine of, this time it's angle B. You could go to a third form. A squared equals b squared plus c squared. This time we've isolated a squared. Well, now we're going to have to say minus 2 times the two terms on the right, 2 times bc, cosine of angle A. Wow. Well, right now, let's immediately jump into this. Thank goodness you've seen this before. Could you draw a picture? Well, I suppose you could. I don't think that it's necessary for you to do that, but you certainly could. Maybe to just jump out at you that very frequently the law of cosines is used for side angle side given information. Side angle side given information. So at this point, guys, which form of the law of cosines do you think we're going to work with? What side is isolated? Absolutely. Very good. Look, the angle that we're given, like I said, is going to show up inside a cosine. That means that we only have one angle that we're working with. So we're going to, by necessity, have to work right here. C squared is equal to a squared plus b squared minus 2ab cosine of angle C. And right now we can definitely plow through this and see where we're going. We can say that a squared, well, that would be 2 squared plus 3 squared minus 2 times 3 times the cosine of 60 degrees. And do you know what? How about we let the calculator do all the work for us, right? How about in the calculator, we type this. Get a load of this. This is wonderful. We can say, I want the square root. The square root of what? 2 squared plus 3 squared minus 2 times 3. Now we know what the cosine of 60 is. The cosine of 60, of course, is 1/2. But hey, let the calculator work it out. Do make sure your calculator is in the correct mode. That's so important. I'm checking myself. We're in degree mode. And right now you could just hit enter. And I'm getting about 2.646. By the way, Mr. Clifford is suggesting on Friday that we just round to 1 decimal place, which is perfectly okay. So expect to probably round to just 1 decimal place. But hey, that being said, it did say to solve the problem. And tell you what, maybe I'll even store that temporarily as a C. You might wonder why on earth I'm doing that. I'm not done with the problem. Solve the triangle means we've got more work to do, guys. We have to find angles. We have to find angles. And guys, there are a couple of ways you could find angles. But rest assured, we have to find 2 of them. We have to find angle A we have to find angle B. Now, at this point, guys, I think it's important for us to realize that the law of sines is a possibility. It really is. The law of sines is always a wonderful possibility, but remember the ambiguous case. Solving for an angle involves saying, hey, maybe that angle could be acute, maybe it could be obtuse. Perhaps there's a way around that. Perhaps there's a way to say, aha, I know this angle that I'm looking for can't be obtuse. What do you think? Yeah, Srini?
Wouldn't you have to compare the side lengths to C?
Yes. Look at C. 2.645, something like that. What's the biggest side in this triangle? It's side B. So angle B would have to be the largest angle. If there is an obtuse angle in this triangle, it must be angle B. But that means that angle A must be acute. Angle A must be small. Why? It's not across from the biggest side. And that, my friends, might help you out considerably. Look, I know we like to use the law of sines. I think most of us do, at least. You could say, wow, isn't it nice when you can just write out like the sine of A all over A, and then you'd say, uh-oh, now we'd have to go the sine of C all over C. We only have one angle to work with. And, you could say sine of A all over 2 would equal the sine of 60 degrees all over this C value. Well, that C value is, 2.646, etc. That's why I stored it, so I wouldn't have a round off. But solving for the sine of A, I could just double both sides, get rid of that 2. And how about I just go back and I put that in there? And, really, guys, I guess what I want you to see is that if I brought up the calculator here, if I made that fraction, if I said alpha y equals, if I said on the top I wanted to have 2 sine of 60 degrees, down below, hey, it was an ugly decimal, 2.6457. Could even go second answer here if I wanted to. But I'd get 0.654, something like that. You don't even have to show this step if you really know what you're doing. How would you get A now? You'd have to do what? Inverse sine. So let's do that. So we're reviewing the law of sines right now. That's always a nice thing to do. And I'll just go second answer. And that's about 40.9 degrees, roughly. Maybe jumping to Mr. Clifford's suggestion of just going to one decimal place. Is there a really clever, fast way to find angle B now? Yeah, let's add our two angles together. We'd say, look, 60 and 40.9 would add up to 100.9 and go 180 minus that. Pardon me. And what is that? 79.1, I guess? I think that's right, unless I made a real silly mistake. And there's your third angle. We have solved the triangle. We found every angle and every side that's located on it. We doing okay? Well, you might have noticed I said that there are multiple ways you can find angles. You could use the law of cosines to find an angle as well. And that, by the way, is preferable to many students because you won't have to worry about a quadrant issue. You see, the thing is, using the law of cosines, you're going to be given either an acute or an obtuse angle when you solve for the angle with the law of cosines. It's not like the problems we had with the ambiguous case using the law of sines. So that being said, sometimes kids look at this and they'll say, I'm sorry, I don't know where to begin. I'll tell you what, let's find an angle. What angle would you like to find first? C. Okay, that sounds good. And by the way, if someone said A, we'll find that next. I thought I heard someone say A. Don't mean to brush that aside. I just heard C first is all. Look, one thing I hope you notice is that, with the law of cosines, we're going to have angle C on that right side and side C on the left. Tell you what, how about we do a little switcheroo? How about we bring 2AB cosine of angle C to the left side and we subtract C squared from the right? Sometimes kids will say, well, why on earth are you doing that? I'm solving for cosine of angle C. And doing that isn't all that bad. You'd say, well, right now I just have to divide by 2AB. Wow, you know what? You're almost done, guys. Because right now, you know what your A is. It's 4. Your B is 3. Your C is 6. Down below, you have 2 times 4 times 3. And tell you what, how about we put that fraction into the calculator, clean it up a little bit. We'll go alpha y equals, and let's type in 4 squared plus 3 squared minus 6 squared. Down below, we'll go 2 times 4 times 3. And hey, you could work all that out for sure. You actually get something friendly, a negative 11 over 24. Sometimes you'll get a decimal. Sometimes you'll get something that looks a little bit more friendly. But how would you find angle C? Inverse cosine. Let's do that. Let the calculator do that. Inverse cosine, second cosine of second answer. And here it is. This is what I'm talking about. It's an obtuse angle. Look at that, 117.3 degrees roughly. Nice. No worrying about, maybe I should look at a second quadrant and a first quadrant and try to determine which is which. No, hey, this is it. You're good to go. And right now, you found the biggest angle in the triangle. Now, right now, suffice it to say, you could even revert back to the law of sines if you'd like. But hey, we've been working through this. How about we do one more little step with the law of cosines just as well? Someone said they wanted to find angle A. And that sounds good to me. We can do that real quickly. Look, you could write this down. You could do a little switcheroo. And then you're just dividing, and all of a sudden kids are going to look at this and say, wow, this is so amazingly close to the last thing that we just did. The only difference is you've got slightly different numbers in there. Your B is a 3 here. 3 squared plus 6 squared minus 4 squared over 2 times 3 times 6. And once again, you can get that calculator up there. How about we do second enter, and get right up there so that you can just change a few things. So just left arrow over here, and we can change that to a 3. Right arrow, change that to a 6. Make that a minus 4 squared. And down below, 2 times 3 times 6. You could just change the 4 to a 6, and that would suffice either way. Here you can see it's 29 over 36. You don't even have to write that down, to be quite honest with you. But you can just hit inverse cosine of second answer, and you'd get about 36.3. Wow. To find angle B, well, add those two angles together.